So we're graphing exponential functions day 2. Before we do, let's go to number 3. Everybody go to number 3. And there's one issue with the equation on number 3. Okay. So equation number 3 is y equals -6 times 1/2 to the x power. All right. So the issue here is, look at your graph. Is there any way we could graph this function here? No. We would need the negative side. So real simple. It's just y equals 6 times 1/2 to the x. Typo there. That negative wasn't meant to be there. So y equals 6 times 1/2 to the x. Okay? All right. Make sure you write that or you get that corrected. Otherwise, we'll have some issues there. The beauty of this is your calculator does most of the heavy lifting. We just have to do the processing and graphing. All right. Let's begin, guys. Put your name on this. Remember, if you finish it in class, you will be able to just turn it in and won't have to take any pictures. All right, let's go. So we have this first function that we're going to graph, y equals 8 times 1/2 to the x. Okay, we're going to do the following. We're going to graph, make the table, build our graph, state the domain range, figure out where the y-intercept is as a coordinate, and we'll also write the equation. Figure out how it changes, and the change in the y value. The change in the y value will also tell us if this particular exponential function represents growth or decay, and we'll talk about that. Okay, so this is our function, and these are our values. So pretty much this point, we're just going to do the calculator. So let's get the calculator, and we're going to set it up. We want 8 times, so I'll put parentheses, 1/2, so 1/ or divide 2. Close the parentheses, and we're going to raise this to the -1 power. Remember, the negative is this button, -1. Okay, and we get 16. So let's go ahead and put 16. Okay, and let's just go ahead and fill in the rest of these values. Although this one we should know without this. Actually, this is going to be where it crosses the... What number should we get for 0? 8. We won't even need a calculator for that one. And I think you'll see the pattern after this. What's happening each instance? Tell me what you get for x equals 1. 4. What's happening each time? Yeah. So this would be 2, 1, and okay. So this is what we get. So now let's go ahead and graph this. So if we have these numbers, we want -1, 16, -1, 16. I tend to make the points nice and big on these, so it's a good target to hit as I'm making my graph. Some of them could be pretty steep. Remember, they call this the hockey the hockey stick function. 0 has to be at 8. Then we have 1 is at 4. And then 2 is at 2. I'm sorry, 3 is at 1. 4 is at 1/2. That one's not too bad right there. We want 5 at 1/4. Oh, I'm sorry. 4 is at 1/2. 5 is at 0.25, 1/4. So it's half the distance up from there. And then 6 is at 0.125, which is half the distance up from there. And will this ever hit 0? Never. Yeah, we're just dividing in half and half and half and half, but never reach that 0. That's our asymptote. Okay. All right. So let's go ahead and now the fun part. You can go from the bottom and connect the points up. You know that how it should look, or from the top to the bottom. But remember, this goes infinitely close to the x-axis, but never hits it. If you're ever not sure of your numbers or graph, you have Desmos to verify it. But it should look something like this. Okay. All right. So now let's talk about domain and range. So domain talks about all the possible x values. I'll highlight all the possible values for x that this would cover. Yeah, this is all real numbers. Basically, anywhere to the extreme negative or to the extreme positive, it would be covered. So this one is all real numbers. Now for the range, we're looking from 0 on up. Never touches 0, but that's our boundary on up to infinity. So we can just say y is greater than 0. Or from 0 on to infinity. Either one. Where did we intercept that y-axis? 0, 8. Okay. Change in y values. So, yeah, 1/2. So each, let's say each value is 1/2 the previous value. You see that pattern is decreasing by 1/2. Okay. All right. Now, the question of growth or decay. It's basically what's happening as you go from left to right. It's decaying, it's dropping. As we go left to right on our graph, it's dropping, it's decaying. If it normally goes from here and increases up, that would be growth. So this is exponential decay. Oh, decay. Okay. All right. So basically, this is what we're going to be doing on these. You got 3 more to do on your own. Once you're done, make sure, you should have your name on it already. Just leave it on the Chromebook cart, and that'll be the assignment. Any questions? All right.